8th grade Open Up Resources, Illustrative Mathematics, Unit 8, Lesson 12, Edge Lengths and Volumes. Problem number 1. A. What is the volume of a cube with a side length of 4 centimeters? The volume of a cube is a cubed, or a to the third power. If the side lengths of the cube are 4 centimeters, then the volume would be 4 to the power of 3 centimeters cubed, or 64 cubic centimeters, because 4 times 4 times 4 equals 64. What would the volume of a cube with a side length of the cube root of 11 feet? The volume of this cube would be the cube root of 11 feet cubed. The cube root of 11 cubed is 11. So the volume of this cube would be 11 feet cubed, or 11 cubic feet. What is the volume of a cube with a side length of s units? The volume of this cube would be s cubed units cubed. B. What is the side length of a cube with a volume of 1,000 cubic centimeters? Since the volume equals a to the third power, in this case 1,000 will equal a to the third power. The 3 dimensions of this 3-dimensional cube can be labeled a. The height times the length times the width will equal 1,000. Since 10 times 10 times 10 equals 1,000, then the lengths of the sides of the cube are 10 centimeters. What is the side length of a cube with a volume of 23 cubic inches? We'll start with the volume equals a to the third power. That stands for the 3 dimensions in the 3-dimensional cube. Height times width times length. A to the third power equals 23, or 23 equals a to the third power. That means that each side length must be the cube root of 23. That means that each side length a is the cube root of 23 inches. What is the side length of a cube with a volume of v cubic units? We can start with v, or volume, equals a to the third power, or a cubed. A to the third power means a times a times a. And in the case of a cube, it's the height times the length times the width. That means that all 3 of these dimensions are v cube units. For this cube, each side length would be v cube units. It's time to do something nice. Like this video, say something in the comments, tell a friend about this channel, and hit that thanks button. Problem number 2. Write an equivalent expression that doesn't use a cube root symbol. A. The cube root of 1. That's asking what number times itself 3 different times equals 1. Well, we know that 1 times 1 times 1 equals 1. So the expression that we can use is 1. B. The cube root of 216. What number times itself 3 times equals 216? That's really just saying what could the side lengths of the cube be, like the height, the length, and the width. Since 6 times 6 times 6 equals 216, the cube root of 216 can be expressed as 6. C. The cube root of 8,000. What number times itself 3 times equals 8,000? Since 20 times 20 times 20 equals 8,000, then the cube root of 8,000 can be expressed as 20. D. The cube root of 1 over 64. What number times itself 3 times equals 1 over 64? Since 1/4 times 1/4 times 1/4 equals 1 over 64, then the cube root of 1 over 64 can be expressed as 1/4. E. The cube root of 27 over 125. That's asking what number times itself 3 times equals 27 over 125. Since 3/5 times 3/5 times 3/5 equals 27 over 125, then the expression 3/5 is equivalent to the cube root of 27 over 125. F. The cube root of 27 thousandths. What number times itself 3 times equals 0.027? Since 3/10 times itself 3 times equals 27 thousandths, then 3/10 is equivalent to the cube root of 27 thousandths. G. The cube root of 125 millionths. What number times itself 3 times equals 125 millionths? Since 5/100ths times itself 3 times equals 125 millionths, then we can use 5/100ths to represent the cube root of 125 millionths. Problem number 3 from 8th grade, Unit 8, Lesson 11. Find the distance between each pair of points. If you get stuck, try plotting the points on graph paper. A. I'm going to plot the points for x and y. X is located at 5 and 0, and y is located at -4 and 0. We can see the difference between these 2 points. The difference between -4 and 5 is 9 units. So the horizontal change is 9 units. The vertical change is 0. B. Now I'll plot the points for K and L. The L is located at 0 and 0. K is located at -21 and -29. As you can see by the line that connects the 2 points, there's a vertical difference and a horizontal difference. To find the difference between these 2 points, we can make this line a hypotenuse of a right triangle. We can use the Pythagorean theorem to help us find the length between the 2 points. The legs of this right triangle are 29 and 21 units. So when we use a squared plus b squared equals c squared, we can substitute the 21 and the 29. So now the equation reads 21 squared plus 29 squared equals c squared. 441 plus 841 equals c squared. C squared equals 1,282. That means that C would equal the square root of 1,282. So the distance between these 2 points is the square root of 1,282. Problem number 4 from 8th grade, Unit 8, Lesson 9. Here is a 15 by 8 rectangle divided into triangles. Is the shaded triangle a right triangle? Explain or show your reasoning. The length on the vertical line on the right is also 8 units, just like the one on the left. We can use the Pythagorean theorem to find the missing lengths of the shaded triangle. Let's use the information that they gave us and find the hypotenuse of the triangle on the left. 9 squared plus 8 squared equals c squared. 9 squared is 81, 8 squared is 64. Since 81 plus 64 equals 145, then c squared equals 145. That means that c equals the square root of 145. We know that one of the missing side lengths for the shaded triangle is the square root of 145. We can find the other missing side length from the shaded triangle by using the information for the right triangle next to it. 6 squared plus 8 squared equals c squared. 6 squared is 36, 8 squared is 64. 36 plus 64 equals c squared. So we know that c squared equals 100. So c is going to equal the square root of 100. Since the square root of 100 is 10, we know that this missing side length is 10 units. Now we can use all the information that we've gathered to help us figure out if this shaded triangle is a right triangle. We're going to use a squared plus b squared equals c squared. So in this case, we can use the square root of 145 squared plus 10 squared equals c squared. They've already given us the length for c, and that's 15. So c squared would be 15 times 15. The square root of 145 squared is 145. 10 squared is 100. 145 plus 100 equals 245. The square root of 245 equals c. Since the square root of 245 is 15.65 and 15.65 does not equal 15, then this shaded blue triangle is not a right triangle. Problem number 5. From 8th grade, Unit 8, Lesson 10. Here is an equilateral triangle. The length of each side is 2 units. A height is drawn. In an equilateral triangle, the height divides the opposite side into 2 pieces of equal length. A. Find the exact height. The 3 side lengths of an equilateral triangle are all equal. So they've given us one indicator. They said that one side length is 2 units. That means that all the side lengths are 2 units. The line representing the height that runs down the middle of this equilateral triangle makes it form 2 right triangles. We're going to use one of the right triangles and the Pythagorean theorem to help us find the missing height. We know that the hypotenuse is 2, one of the legs is 1, and the second leg, which is the height, is unknown. So now our equation reads 1 squared plus b squared equals 2 squared. 1 squared is 1, b squared is b squared, and 2 squared is 4. Now we're solving for b. We'll subtract 1 from both sides of the equal sign. Now we're left with b squared equals 3. That means that b equals the square root of 3. So the missing height is the square root of 3. B. Find the area of the equilateral triangle. The area of the triangle is half of the base times the height. In this case, the base is 2, and the height is the square root of 3. We can write that as half of 2 times the square root of 3, or 2 times the square root of 3 divided by 2. This is equivalent to the square root of 3. The area of this entire equilateral triangle is the square root of 3 units squared. C. Challenge. Using x for the length of each side in an equilateral triangle, express its area in terms of x. The area of a triangle is half of its base times its height. The base would be x, and the height would be the square root of 3. So half of x times the square root of 3 units squared. Be sure to support my YouTube channel by liking this video and hitting that thanks button. Thanks for watching, and I'll see you next time.